In computing, thin provisioning involves using virtualization technology to give the appearance of having more physical resources than are actually available. If a system always has enough resource to simultaneously support all of the virtualized resources, then it is not thin provisioned. The term thin provisioning is applied to disk layer in this article, but could refer to an allocation scheme for any resource. For example, real memory in a computer is typically thin provisioned to running tasks with some form of address translation technology doing the virtualization. Each task acts as if it has real memory allocated. The sum of the allocated virtual memory assigned to tasks typically exceeds the total of real memory. The efficiency of thin or thick fat provisioning is a function of the use case, not of the technology. Thick provisioning is typically more efficient when the amount of resource used very closely approximates to the amount of resource allocated. Thin provisioning offers more efficiency where the amount of resource used is much smaller than allocated, so that the benefit of providing only the resource needed exceeds the cost of the virtualization technology used. Just-in-time allocation differs from thin provisioning. Most file systems back files just-in-time but are not thin provisioned. Overallocation also differs from thin provisioning. Resources can be overallocated/oversubscribed without using virtualization technology, for example overselling seats on a flight without allocating actual seats at time of sale, avoiding having each consumer having a claim on a specific seat number. Thin provisioning is a mechanism that applies to large-scale centralized computer disk storage systems, SANs, and storage virtualization systems. Thin provisioning allows space to be easily allocated to servers, on a just-enough and just-in-time basis. Thin provisioning is called sparse volumes in some contexts. Overview: Thin provisioning, in a shared storage environment, provides a method for optimizing utilization of available storage. It relies on on-demand allocation of blocks of data versus the traditional method of allocating all the blocks up front. This methodology eliminates almost all white space, which helps avoid the poor utilization rates, often as low as 10%, that occur in the traditional storage allocation method where large pools of storage capacity are allocated to individual servers but remain unused. This traditional model is often called fat, or thick provisioning. With thin provisioning, storage capacity utilization efficiency can be automatically driven up towards 100% with very little administrative overhead. Organizations can purchase less storage capacity upfront, defer storage capacity upgrades in line with actual business usage, and save the operating costs associated with keeping unused disk capacity spinning. Thin technology on a storage virtualization frame was first introduced by Data Core Software. Previous systems generally required large amounts of storage to be physically pre-allocated because of the complexity and impact of growing volume space. Thin provisioning enables overallocation or oversubscription. Overallocation overallocation or oversubscription is a mechanism that allows a server to be more storage capacity than has been physically reserved on the storage array itself. This allows flexibility in growth of storage volumes, without having to predict accurately how much a volume will grow. Instead, block growth becomes sequential. Physical storage capacity on the array is only dedicated when data is actually written by the application, not when the storage volume is initially allocated. The servers, and by extension the applications that reside on them, view a full-size volume from the storage, but the storage itself only allocates the blocks of data when they are written. As a practical consideration, a storage manager needs to monitor actual storage used, adding additional storage capacity such as disks, tapes, solid-state drives, etc. as necessary to satisfy the write requests of the server and residing application. The overallocation concept was first introduced when Storage Tech announced their Iceberg product in 1991. Banking analogy There is an analogy between thin provisioning in computers and the keeping of cash reserve ratios in banks. Much as all processes running on a computer whose memory is thinly provisioned may not simultaneously use the sum total of their allotments of memory because it does not all exist in the computer at one time. All depositors to a bank may generally not simultaneously close their accounts by taking cash withdrawals whose combined total does not exceed the cash kept by the bank. A solvent bank is able over time to remunerate its depositors. This requires some combination of the solvent bank earning cash from its investments, collecting its loans, selling its investments for cash, attracting new shareholders, and attracting new lenders or depositors. See also, logical volume manager, statistical multiplexing, storage hypervisor, storage virtualization. References. External links, Wikibon Thin Provisioning article.